All right, let's pull that up. So for those of you guys who actually completed the questions, do help me out here because I didn't do these questions beforehand. So just to make it go by faster, so it'll be helpful for you guys to, you know, help me through some of these calculations and stuff. All right, so this is question 6. No, there's no answer key because I didn't even do the question, so there's no answer key. But we'll go over it now. So this is question 6. I believe this one's integration by parts. So you can tell because it's a product of two functions. And does anyone know how many times we need to do the by parts formula for this question? Yeah, so you need to do it twice here. And why do you need to do it twice? How can you tell? Right, so you look at the exponent for s. So because it's x squared, we know that we'll have to do integration by parts twice. So let's do this. What is your u and what is your dv?
Professor, are we allowed to take the 4 out?
Oh, yeah, you can do that. So, yeah, let's do that first. So who remembers which one goes for u?
S squared.
Yeah, s squared. Your other choice would be cosine of x, but who remembers why cosine of x shouldn't be used for u?
Because we're integrating for ds. Like you want whatever u to turn into du so that it spits out ds at the end. So if you do s squared for u, you would get 2s ds, and you're looking for the ds.
Did I make a typo here? Yeah, there's actually a typo in this question. This is supposed to be cosine of s. The variables are supposed to be the same. Okay, sorry, could you repeat what you just said?
Now it doesn't make sense. I was thinking originally, since if you do cosine of x, you're not really integrating x.
Yeah.
Yeah, it's a different answer. The reason you're doing it now is because it's easier to do, well, you'd have to do it twice regardless. So cosine would be the v next time.
Well, if s squared is u, then the cosine of s would be the dv. ds. But do you guys remember what I said as to like the tip to remember which one is probably the u?
We can't put s squared into dv because when we take the antiderivative, it would be a greater, how do you call it, degree, which means that we're just going to increase. We're not making it smaller, which means that we'll never get to the end of the integration.
Yeah. That's really the main idea. I think the exact word I said was u is usually the function that gets simpler as you take the derivative. So,
Professor, if I may,
mhm.
I saw on the internet there's like this little acronym. I'm just gonna put out here on the side, LIATE, and then from top to bottom, it's what's easier to integrate. So
Mhm.
you'd start with logarithmic. You would want to do uh, logarithmic first,
Mm.
and then you'd go on to I think it's improper. I'm not sure if it's improper or integer, but then I know it's arithmetic
Inverse.
after that.
It's inverse.
Oh, it's inverse. Okay, my bad. Let me erase that. Yeah, it looks like somebody here already knows what I'm talking about.
Yeah, I mean, if you remember what the acronym was, feel free to write it. I don't know what this is though.
Arithmetic. Then it's trig, and then it's exponential. And then basically, like from one way to the other, it's easier to integrate, and then from the other way, it's easier to derive, or something. Maybe vice versa. I don't remember that like specifically, but I remember like this thing in general.
Okay, yeah, I've never heard of it, but hey, if you found something that helps you decide which one's better, then yeah, by all means, you can use it. I mean, I don't know. I didn't learn much acronyms. Like I didn't know what SOHCAHTOA was until I taught like pre-calculus. So yeah. um, du is 2s ds, and then the integral of cosine is sine. Okay, so applying the by parts formula, we will get 4. So the formula says it's u times v, so s squared times sine of s minus the integral of v du. So this would be 2s times sine of s, close parentheses, ds, and then close.
And then we do it again to get rid of the s.
Yeah.
And then,
so let me just write down these substitutions again. U is s, and then dv is sine of s ds. So if you choose this, then du is 1, and v is, was it negative cosine?
wouldn't s become ds though?
Oh, yeah. It'll be 1 ds, yeah. Usually when we take derivative, you write the differential afterwards. Okay, so let me just carry everything over. This is 4 s squared sine of s minus, I'm going to pull the 2 out before I make this by parts formula. So 2. So in order to evaluate this particular section, we have to use by parts. So this would be u times v, which is negative s cosine of s, minus the integral of v times du. So that would be negative 1 cosine of s ds. And then close two parentheses. All right, so this is after our second integration by parts. So we should be able to finish this now without using another by parts. And the only thing we need to evaluate is this integral right here. So we have 4 s squared sine of s minus 2. This is negative s cosine of s. These two negatives make it a positive. And then the integral of cosine is sine. Okay.
Of s ds. Oh no, just of s.
Yeah, of s. You don't need to write ds because we integrated. So close parentheses and then close parentheses. And then you add plus c.
And then we just make it, simplify it if we want to.
If you want to, I probably would just stop here. Okay, so this would be your answer. All right. Is everyone good on that?
Professor, so what chapter are we really up to in terms of Lumen? Because I'm not saying due dates.
The due date should be on Lumen. Let me see.
I only see October 10th for chapter 5, and that's it.
So we should be done with chapter 5. The due date should all be October 6th because that's when our exam is. But we're done with chapter 5. On chapter 6, we're up to 5.2. Sorry, 6.2 on chapter 6. Yeah, there was a typo. There was the question said cosine of x, but it was only cosine of s. Yeah. All right, so we have a request for number 5. So let me see what number 5 is. Okay, so number 5 was a word problem. All right, so this is number 5. It reads, the population of deer in a habitat grows exponentially at an unknown rate. So, okay, right away from that first sentence, which formula should we use for this question?
Per.
Yeah, per. So we have A equals, let's use a different color. let's use gray because we can't use colors here. A equals PE to the power of RT. Okay. Suppose why is the capital? Suppose the initial population was 250 deer and grew to 700 at the end of the first year. Okay. So right away, they gave you two pieces of information, right? The 250, what is that? Yeah, so the 250 is P. We call that the principal amount or starting amount or initial population, whatever you want to call it. So P is 250. And then 700. How can we use 700? What's that? A. Well, it is A, but it's more to that. So it's A when what?
When t is equal to 1.
Yeah. So because technically A is a function of t, right? So A of 1 is 700. Okay, so using this information, let's see what we have. So we have P is 250, E to the R, T. So when T is 1, then our A is 700. In this equation, what can we solve for here? Yeah, so we can solve for the rate, R. So let's go ahead and do that. 700 over 250 is E to the R times 1. So just R. And then to solve for R, you have to take the natural log of both sides. So R is natural log of 700 over 250. Okay. Um, 1.03. Is that like the decimal for R? Okay. Approximately 1.03. So, all right, yeah, whatever. So the question wants you to find the population of deer at the end of year 3. So they're asking you to find A of 3, right? So let's see if we have enough information to do that. We know the principal amount, 250. We know E, and we know the rate now. So this is approximately 1.03, and the time is 3. So this equation will give you the population at year 3. And then someone with a calculator, can they just tell me what number they get? 5488. Okay. Dear. You got 5494. Yeah, I think depending on if you round R or not, you'll get a different answer. So just double check what R you used. Should you not round on the exam? You know, I guess I'll just specify what you have to round to on the question on the exam. So in the question, I'll specify maybe like round all intermediate steps to maybe 2 decimal places or whatever. But yeah, I mean, as far as if I forget to like, say round or whatever, like that's why it's good to show your work so I can see if you did it correctly. Because if I see that you rounded and you use your rounded number and you did it correctly, then it's all fine. The second part of the question says to find the rate of growth of the deer population at the end of year 2, t equals 5. What? Yeah, year 2 is not t equals 5. Year 2 is t equals 2. T equals 5 is year 5. Sorry, that must be another typo. But that's not really the important part here. So when they say find the rate of growth of the deer population, what is that referring to? Yeah, so the rate of growth of the deer population is the derivative of the deer population equation. So what we have right now is the equation A of t equals 250 e to the 1.03 t, right? So if we take the derivative, we should get, yeah, it's just the rate times the original equation. But if you don't remember that, you can just use your knowledge of derivatives. So it's 250, the derivative of e stays the same, 1.03 t, and then times the derivative of the exponent. So that's times 1.03. So that's the derivative equation. This represents the rate of growth of the deer population at time t. So if we wanted to say find the rate of growth at the end of year 2, then you would find a prime of 2. Or if it was year 5, you would do a prime of 5, right? So this would be 250 e to the 1.03 times 2, 1.03. Okay, and then you'll get your answer for that. Any questions on that? Okay. Yeah, so I'll make sure to proofread the exam when I make it, and I'll do all the questions myself, just so like there's no typos. All right. If that's good, then let's move on to another question. Any requests? Number 4. Sure, we can do number 4. So this is number 4. Yeah, this one is there's no typo here. That one is supposed to be a y and sine of x. So here we want to take the derivative. So remember that d dx is another way of saying derivative. There's a lot of ways of saying derivative. So d dx is one way. Another way is to say f prime. Some people might write dy dx, or some people might write f prime of x. These are all ways of saying derivative. Or sometimes y prime, doesn't matter. Anyways, for this one, it's exponential, right? E, and then there's a exponents that requires which rule? So what derivative rules do we need to solve this problem? Yeah, so for the exponent, we'll need product rule. You'll also need to remember the derivative of e to the x, right? Because that's the main function. And you'll probably also need to know derivative of sine. So let's see if we can do this. The 3 is just a constant in the front, so we can just ignore it and take the derivative of the rest of the function. So the derivative of e to the x is just e to the x. So the first part stays the same.
Professor, I'm just gonna remove this extra stuff that I put down.
Okay. And then we have to multiply by the derivative of the exponent. So that's from chain rule. So before I take the derivative, let me just write down that I'm going to take the derivative. So it's times d dx of this. Okay, so let's go ahead and take the derivative of this exponent. So it's 3 e to the y sine of x. We said we need product rule, so let's go ahead and do that. Product rule says, first we can take the derivative of y. So here, because this is d dx, right? The question says to take the derivative with respect to x. That means that x is a variable and every other letter is a constant. So imagine if y was just a constant when we take the derivative. If it's just a constant, then the derivative of y is 0. Okay, we can leave the other part the same. So square root of sine of x plus, now we leave y the same and we take the derivative of square root of sine of x. So taking the derivative of square root of sine of x, let's do that on the side because that's multiple parts. So this is what we're looking at. This is the same as 1/2. It's sine of x to the 1/2 power, right? So how can we take the derivative of this? Recall that you bring the exponent to the front, and then you subtract 1 from the exponent, and then you have to multiply by the derivative of sine of x. So that's cosine. Okay, so there's your derivative of square root of sine of x. 1/2 sine of x to the negative 1/2 times cosine of x. Close and close. Okay, so there's your answer. That is your derivative. I hope you guys like that answer. Any questions? By the way, I'm missing one pair of parentheses. So this is the derivative of the exponents. Okay. Yeah, so because we specify it's d over dx, that means that every other letter is just treated as a constant. So y is just a constant. So it goes to 0 when you take the derivative. All right. So we did number 9. And we did number 5, and then that was number 4. What would you guys like to do next? Number 1. We did segment 9. Oh yeah, you're right. My bad. Okay, number 1. Number 1. All right, let's do that one. So this is number 1. Just by looking at it, does anyone know what's the approach for this question? You're guessing integration by parts. Yeah, probably. I feel like that's the only integration method we learned, isn't it? Like in cal2 so far. But okay, yeah, it's integration by parts. But more specifically, what is the process going to look like? Like, do we need to take it by parts once or twice, or maybe something else? Twice. Yeah, it is going to be twice. But do you guys remember like if there was anything special about this question? Yeah, combine the integral. So recall that by parts, you have a u and a dv. Usually the u function is the one that has a simpler derivative. So if you look at these two functions, one is e to the x, the other one is a trig function, sine of x. So choosing the one that's simpler, you can't really tell because e to the x just repeats itself when you take the derivative. And same with sine of x, right? It just cycles between sine and cosine. So for this one, the key was just take it twice, and then you actually realize that the same integral comes out again, which you can combine. So let's take a look at it. It won't really matter which one you choose for u and dv. So I'm just going to choose whichever one. I'll just choose e of x. And then du is e of x dx. So dv is sine of x dx. And then the integral of sine is negative cosine. All right. We can factor out the 3, right? So when we get our final answer, we can just multiply it by 3. Okay. Okay, so right now let's try to do this part right here. The by parts formula says we're going to have u times v. So this is negative e to the x cosine of x minus the integral of v du. So that's minus e to the x cosine of x dx. Okay. All right. Let me just combine the two negatives. So this is plus. Okay, now we have to solve this integral right here. So that will require another by parts. So let's write out another set. We're gonna have u be e to the x and dv be cosine of x dx. This is sine. All right, so after this, we will have negative e to the x cosine of x plus. So for this integral, we will have another by parts formula. So by parts formula says it's u times v, so e to the x sine of x minus the integral of v du. So this is e to the x sine of x dx. Okay, so it seems like we're going in circles, but we already knew how this question goes. Recall what's on the left-hand side of our equation. The left-hand side of our equation is this part right here. So we have e to the x sine of x dx, right? So notice how what we're trying to find is actually the same thing as this term over here. So what we can do is we can just move that second term to the left-hand side of the equation, which will give us which will give us two of these integrals. Okay, and then I'll just copy everything over. All right, and then to solve for the integral, we can just divide by 2. We're going to carry the 3 at the end. All right, we haven't gotten there yet. So when we divide by 2, we will have integral of e to the x sine of x dx is all of this. Divided by 2, right? So we have just found the answer to basically this part of the question. So we just need to multiply our answer by 3. So let me go ahead and do that. So our final answer is 3 times all of this plus c. Okay. All right. So that's that question. Can we go over 9? Yeah, 9 is fine derivative. We can go over 9. Oh. Is there a reason why you guys don't ever open your webcams? Like, do you do it on the on other classes or no? Because it's not required. Only one required. Yeah, I mean, I'm not gonna require because it's like privacy, you know. But I don't know. I feel like part of the professor-student experience is like facial expressions. So I don't know. It could be helpful, but I'm not gonna require it. So this is question 9. It says to find derivative. So this one is natural log of some product. All right. So right away, we're going to need to know the derivative of natural log function, right? So for those of you who remember what that is, you can just type it in the chat. And then when you apply chain rule, you're going to need to take the derivative of what's inside the parentheses, right? So that requires product rule. So the derivative of ln is 1 over x, right? So this is 1 over x over x squared plus 1. And then chain rule says take derivative of the inside. So that's product rule. We take the derivative of x, which is 1. We leave the next part the same. And then we just put everything in brackets. And then we leave x the same, and then we take the derivative of square root of x squared plus 1. So that would be 1/2 x squared plus 1 to the negative 1/2 times 2x, right? Close parentheses. Yeah, let me know if you need to explain any part of that. That's question 9. Yeah, I believe so. Yeah, we found a derivative. That's the derivative. Why do we have the 2x at the end? So this 2x is chain rule after we took the derivative of the square root of x squared plus 1. Let me just do that on the side, just so it's more explicit. So we're trying to take the derivative of square root of x squared plus 1. So this is basically to the 1/2 power. So the exponent goes to the front, and then you subtract 1 from the exponent. But then there's another inside function that requires another chain rule. So that's why there's another 2x. Okay. Perfect as looks. Sure, yeah. Yeah, I mean, some of these questions don't require too many steps. You know, I think it's because I don't like simplifying, so that's why it seems shorter than normal. Question 8. Yes. I believe question 8 also had a typo, but let me just go over it first. All right, let's make it make it whatever, gray is fine. This one says to evaluate the integral. Okay, so part of the struggle for these questions is being able to identify the special form of this integrand. So can anyone see it? Yeah, it's arctan. So recall that the integral of 1 over 1 plus x squared dx, that's arctan of x. So this question looks really close to that form, and you could probably get it in that form with some manipulation. So that's really the plan for this question. Okay, so first I'm going to just take out the 7. And then I'm going to, instead of writing the dx in the numerator, I'm going to write it on the side because that looks more normal, maybe. I don't know. 4x squared dx. And then we want to get this term here, this 4x squared, into just one variable squared. So we're going to need to do a u substitution. And what would that u substitution be? U equals 4x squared, 2x. Which one is it? 2x, x squared. That's a lot of answers. So we want the final form to be 1 plus something squared, right? So if we choose, so let's see what happens if we choose u to be 4x squared. If we do that, then we will have 1 over 1 plus just u. So that's not really in the form of arctan, so that wouldn't be quite right. So u wouldn't be 4x squared, unfortunately. But what should it be? Someone said 2x. Let's see if that works. If it's 2x, then we will have 1 over 1 plus what goes here? U. Yeah, I think that's u squared, right? So notice if u is 2x, then u squared is 2x squared, which is 4x squared, right? So this is the correct substitution. I guess the main idea is you want to take this term right here and just take the square root of it. That'll give you the appropriate u substitution. All right. If u is 2x, then du is 2 dx. Okay. So using this u substitution, let's rewrite the integral. So it's integral of 1 over 1 plus u squared. We also have to fill out the dx, right? So dx is just du divided by 2 if we were to put the 2 over there. So let's put that in. Dx is du divided by 2. All right, so now it's in the form of an arctan integral. So this is 1/2 arctan of u. Okay, and then I guess we'll do it the way where we put it back in terms of x. So this is, go here, 1/2 arctan of what was u? U was 2x. So this is what we have. Now that everything's in terms of x, we can use our original limits. So 0 to radical 3 over 4. Okay.
I have a question.
Yeah.
What happened to the 7?
Oh yeah, I was gonna carry over like at the very last step, but if you want to, you can just like put everything in parentheses and then write 7.
Mm-hmm.
So right now we need to evaluate it at the top and bottom limits. This is 1/2 arctan of, so first I'm going to plug in radical 3 over 4 for x. So that'll give you radical 3 over 2 minus 1/2 arctan of 0. Radical 3 over 2. Wait, is that on the unit circle for arctan or no? I don't remember. Is there an angle on the unit circle that has a tangent of radical 3 over 2? It's not. Yeah, I think that's where my typo was. So it's not. I didn't mean to write square root of 3 over 4 here. So this should have been square root of 3 over 2. My intention was to give you a limit that would give you a number here that you can just look on the unit circle and find the arctan of it. But yeah, there's another typo. So this is supposed to be 1/2 arctan of radical 3 minus 1/2 arctan of 0. Okay, and those are points that you should be able to find the arctan of. So let's finish this. What is arctan of square root of 3? Pi over 3. Okay. Minus 1/2, and then arctan of 0 is, where's the, what angle is this tangent 0? Or what angle is the slope 0? I think that's at 0, right? Okay, so there would be your answer.
I missed the part where it went from radical 3 over 4, and well, what happened? Where did the radical 3 over 2 come from?
Yeah, so the radical 304 is actually a typo because when you plug it in to try to solve for arctan of radical 304, it turns out to be an angle that's not on a unit circle. So I didn't mean to write radical 304. So this is supposed to be what I meant to give you guys. Because if you put radical 3 over 2 into x, then you can find the arctan of it. How did radical 3 over 2 turn into radical 3? Yeah, let me just, oh no, it's because if the upper limit is radical 3 over 2, if you plug that into x right here, then it's 2 times radical 3 over 2, and then the 2's cancel out, and you're just going to be left with radical 3. Okay, so this one is not supposed to be, this is the word for the typo. Number 7. Okay, number 7. All right, this one says to evaluate the limit. Limit as x approaches 0 of cosine of x minus 1 plus 1/2 x squared, all over 2x to the 4th. Okay, so recall for limit questions, you always want to just plug in the x value and see if you get an answer. So if we were to try that, we get cosine of 0 minus 1 plus 1/2 0 squared all over 2 times 0 to the 4th. So this is, I mean, if you know anything about math tests, it's usually never like that, right? So this is probably an indeterminate form. I think we get 0 over 0 here. So because we get an indeterminate form, you need to use L'Hopital's rule. So L'Hopital's rule says that if you were to take the derivative of the numerator and denominator, it'll be the same original limit. So limit as x approaches 0. To take the derivative of the numerator, we get negative sine of x. The 1 goes away, then plus x, right? Divided by 8x cubed. All right, so let's try it again. When we plug in 0 into this function, what do we get? This will be negative sine of 0 plus 0 over 8 times 0 cubed. Does that give you something? Well, the denominator is undefined, right? So probably not. Negative sine of 0 is that 0? What was sine of 0? This point here is 1, 0. Sine is the y value. Yeah, it's 0. Yeah, so this is still indeterminate form, which means we need to take the derivative again. So the derivative is negative cosine plus 1, 24x squared. All right, it should work now, right? So this is negative cosine of 0 plus 1 over 24 0 squared. What does that give you? Well, cosine of 0 is 1. So we have negative 1 plus 1 over 0. Unfortunately, it's still indeterminate. So looks like we need to do it again. The derivative of negative cosine is positive sine. And then derivative of 1 is 0. This is 48 x. All right, this has to be the end. We have to get an answer here because this is getting ridiculous. So sine of 0 over 48 times 0, what's that?
Zero over 0.
All right, this is crazy. So this is 0 over 0, which means we need to do it again. So this is limit as x approaches 0. The derivative of sine is cosine, and derivative of 48x is 48. All right, this has to be the end. Cosine of 0 over 48, what's that? Cosine of 0 is 1. So 1 over 48, all right, we finally got it. So this was an exercise on L'Hopital's rule, and this one required 1, 2, 3, 4 derivative cycles, okay? All right, so that's that one. Did we go through all the questions or no? We still have, I think, 2 more. What time is it? 6:53. Okay. Any suggestions? 3. With the question mark. So are you asking if we want to go over 3? You have to be confident in what you suggest. 3. Okay, great. So let's do number 3. All right, so this one is some trig stuff. We probably have to split one of the functions, but we don't know which one. But do you guys have any suggestions? break apart secant squared. So you want to break the secant to the fourth as secant squared? Is that, okay. Let's see what happens if we do that. So this is integral of secant squared of x times secant squared of x. And then we have a tangent to the fourth of x dx. Okay, I've done what you said. Do you have another suggestion? Make u equals tangent of x. Okay, let's see what happens if we do that. So if u is tangent of x, then what's the derivative of tangent? Yeah, the derivative of tangent is secant squared of x dx. Yeah, I think that might work. So we have a secant squared of x here, and the dx is there. So this tangent to the fourth is your u. So if we want to make this work, we'll have to turn this in terms of tangent, right? So how can we turn secant squared of x to be in terms of tangent? Because if we can do that, then we can use this u substitution. You can use the secant 1 plus tan. Yeah, so there was a Pythagorean identity that says secant squared of x plus tan squared of x equals 1. So that means that secant squared of x. Is this identity right? Let me know if I make a mistake. Equals 1 minus tan squared x. Oh yeah, okay, sorry. That was not the identity. Let me just copy and paste the identity from the website, just so we have it for reference. So this is the trig identities. We're using that second one, right? We're using this one right here. Yeah, I had it mixed up. Yeah, sorry. So using that identity, we can rewrite the secant as 1 plus tan squared x. I don't like how that looks. And then I'll put the tangent to the fourth here. And then I'll put the secant squared at the end. Okay. So this is good because this is our du, and then all of this can be rewritten in terms of u, right? So if we write in terms of u, this will be 1 plus u squared times u to the fourth, and then secant squared x dx is du. Okay. Now we can just distribute and then integrate. So let me do that over here. u to the 4th plus u to the 6th du. All right, we can integrate now. So this is u to the 5th over 5 plus u to the 7 over 7 plus c. And then we have to put back the substitution. So u was tangent. So this is tangent to the 5th of x over 5 plus tangent of 7 of x over 7 plus c. Okay. All right. So yeah, this one used the Pythagorean identity. I think we've done mostly trig functions or trig integrals that use Pythagorean identities, and I don't think we've done quite a few words like some other trig identities. So probably on exam, it's probably going to be one that uses one of these Pythagorean identities. Okay. The other ones, the other identities sort of require you to be creative, and like I think that's a little bit too much to ask for. What happens to the secant squared? This part right here. That's du. Du is secant squared x dx. Yeah. All right, so we have one last question to do. Look at that, we had enough time. This one, question 2. So this one says to find integral of sine cubed cosine to the 8th of x. So this is also one where you have to split one of them. Which one do we split here and why? Sine cubed, you want to split that one? Because it has the smallest degree. Because it has an odd exponent. Yeah, so the reason why it is the sine one that you want to split, but the reason why is actually because it's an odd degree. Yeah, so it's not always one with a small degree, and you'll see why in a second. So let me just split it first. We can split into sine squared of x times sine of x cosine 8 of x dx. All right, so notice how this is sine to the first power. Because it's to the first power, chances are we can use that as our du. So along with this, if we use sine of x, or if sine is our derivative, then what was the, let me rephrase that. If sine is our du, then what's our u? Cosine, right. So we want to have everything else in this in terms of cosine. So this is already in terms of cosine, so that's fine. But we want to write this in terms of cosine, right? And are we able to do that? The answer is yes, because I like to answer my own questions. the answer is yes, because we can use another one of those Pythagorean identities, right? It was sine squared x plus cosine squared x equals 1. And this identity has powers of 2, which is why this needed to be in powers of 2. So that's really the reason why you want to split the one with the odd exponent. So for example, if you had like sine to the 5th of x, you can split that into sine to the 4th of x and then sine of x. And then this is for your du, and then this you can turn into cosine. So that's really the explanation to why you want to split the odd one. It's not really like which one's smaller, but which one's odd, okay? So we want to rewrite everything in terms of cosine. So sine squared of x is going to be 1 minus cosine squared of x. I'll write the cosine 8 of x here, and then I'll write sine of x dx here. So we said that u can be cosine, which means du is negative sine of x dx. Okay. So let's rewrite it in terms of u. This would be 1 minus u squared. This is u to the 8th. So here we have sine of x dx, but here we have negative sine of x dx. So we can just divide both sides by the negative. So this is just du divided by a negative. So I'll write the negative here. So you have to set u as the one that you aren't splitting. Yeah, that's right. So we have -1. I'll distribute. This is u to the 8th minus u to the 10. Okay. So this is -1. If I integrate, I will get u to the 9 over 9 minus u to the 11 over 11. Right. Let's put the cosine back in. So -1 cosine to the 9 of x over 9 minus cosine of 11x over 11 plus c. Okay, any questions on that?
Professor, where did you get the u to the 10th power? Did you just do FOIL basically?
What's FOIL?
Okay, that's another abbreviation. But like, did you just
I just multiplied it out.
the 8? Okay, got you. Thank you.
Yeah. So are we all good? Yeah. Any questions on anything we went over on the review sheet? Just give you guys just 1 minute to type any questions. Okay, so if there's no questions, then let's talk a little bit more about the exam. So it is on October 6th. I'll upload the exam probably 15 minutes prior to when class starts. Then you'll have until 7, I think 25 to submit it, okay? Now, before I let you guys go, I just want to have a talk with you guys on something that I think no other professor wants to talk about. And that is cheating, okay? So right now I'm talking to you guys not as a professor, but like as a friend, okay? And why you should cheat or why you should not cheat. So let's have a real talk right now. First thing I want to ask is, do any of your other professors force you to share your screen while you take an exam?
Nope.
Nope. Some? Nope.
The most they asked us to do was to like stay in the session while we're taking the exam. On like
Turn on the
Zoom or
webcam. Yeah. Okay. So most of you haven't, but a couple of you have. I've actually had one friend who the professor forced them to turn on the webcam and share their screens. What is lockdown? I don't know what lockdown is, but here's my issue with that. So if I was going to prevent cheating, none of those methods is going to prevent the student from actually cheating, right? Because they can't just go on another device or whatever. Like if someone wanted to cheat, they would find a way. So that's why I don't know if you guys noticed, but I'm not the strictest professor ever. But I'm not gonna have you turn on your webcams. I'm not going to have you share your screens or anything like that. But let me give you guys an argument as to why you should not cheat. Okay. So there's a thing called the honor system, which means I'm gonna trust you guys that you're not gonna, just put everything on Symbol Lab. But really what you're doing is like, you're here to learn cal2, right? So when you're cheating, you're basically accepting the fact that you failed to learn what like promised yourself you would learn. So you're just lying to yourself as to like what you can and cannot do. Another thing I want to touch on is, I know most of you guys probably will not use Cal2 in a later course. So you guys just want to get like an A and just be done with it. If that's your argument, then you know what, I totally understand you, like you're just gonna go past with no Cal2 knowledge. But basically what I'm trying to say is I'm gonna trust you guys not to cheat. All right?
Professor, I have a request.
What's up?
Can I request that you play some mellow Minecraft music while we take the exam? For those who
No,
might have
sorry,
anxiety.
I don't think, well, okay, here's what my reply to that is. If you want to have music for when you take the exam, put it on your own computer, because
I was joking. I was joking.
If I do it, everyone hears it. Yeah. But yeah, I'll be in the Zoom call to answer any questions. I'll be muted. Everyone else will be muted. Okay. The only reason we're in a Zoom call is just so if anyone has any questions, like if God forbid, I make a typo or something. So yeah.
Oh yeah, another question. Serious question this time.
Mm-hmm.
The exam for everybody is going to be the same, right? So if somebody asks a question during the exam,
the exam is. I'm too lazy to make another version, so whatever.
Right. So if you were to answer a question during the exam for somebody else, that would also benefit everybody.
Right. Yeah. It's good. Like when I reply in the chat, it's gonna be to everyone. So yeah.
Okay.
All right. So is everyone good? The exam is going to be uploaded to Blackboard, and it's not multiple choice. It'll be like this review sheet. The exam is the same like pre-calc. Yeah, I mean, all right, because a lot of people ask me this. So how similar are the exam questions to the review sheet? For example, say look at number 1, for example. So that one is integration by parts, but more specifically, integration by parts that requires you to do it twice and then combine the two similar integrals to the left-hand side. So on the exam, there will be a question like that, okay? It's not going to be 3e to the x sine of x, but it will basically do the same process. If you forget a negative sign, I'll probably take off 0 points if everything's correct. I mean, it's not different numbers. Like I could give you a different function as well, but it'll still require like the same process. 9 questions. All right, okay, so hopefully I've convinced you guys to not do anything that's bad, and I'll be here to answer any more questions. If you're okay with all the questions and you've gotten all the information you need to know, then we can just stop here, okay? So you're free to go. I'll see you guys Tuesday for the exam.
Thank you, Professor.
Have a good night, guys. Good luck on the test.
Is the lowest test grade drop for the whole semester? I don't remember. Was that on the syllabus? Let me see. Yes, so the syllabus does say the lowest exam is dropped, so yes. Have a good weekend.